Hi, everyone. So today I'll be presenting AVA, which is Administrative Virtual Aid by Duke AIPI. So the purpose of AVA is essentially to be a chatbot assistant that's specifically tailored to answering certain questions regarding potential questions regarding AIPI students when coming to Duke for the first time. And it covers a wide variety of topics related to the program, as well as Duke in general. So in terms of data preparation, one of the first things that we did was web scrape the Duke University website, specifically the AIPI program website, as well as the frequently answered questions or frequently asked questions document. And using this tandem of information, we were then able to create embeddings using the GIST embedding model. And we were able to store those chunks within MongoDB, which was our choice of a vectorized database. And once we were able to have all that information in MongoDB, we were able to use GPT 3.5 Turbo in order to use those curated information data set in order to create question and answer pairs based on that data we were just talking about. So this was our data preparation pipeline.
And for model fine-tuning, we started off by taking the dataset street just discussed, which was a combination of context, question, and answer, and then uploaded that to Hugging Face. And then after loading it in for training, we also put it into a certain specific prompt that the model was then trained on, and the prompt is here on the slide. And as for the model, we used the Mistral 7B based model where we loaded in certain parameters for the bits and bytes configuration, converted to a PEFT or parameter efficient fine-tuning model, and then set some LoRa parameters and certain model parameters like the temperature and the max number of tokens. And then we also had some training parameters. Specifically, we trained on for 200 epochs and used a version of AddNW for the optimization technique before finally deploying it as an AI inference endpoint on Hugging Face.
So for the system architecture, it's pretty much composed of a Next.js front end that was deployed with Vercel and a Flask backend that was deployed through Heroku. So I'm just going to walk you through the pipeline. So we have the user who sends the message through the front end. So that's the user input. Then that message is sent to the backend, and then we are embedding that message using GIST embeddings through a Hugging Face dedicated inference endpoint. So rather than just running the GIST model within the Flask app, we decided to use an endpoint instead. And while we are compromising a little bit with latency, we're saving a lot in terms of the application overhead because we don't have to run that model locally, and we're saving a lot of memory. And we figured that was a worthy trade-off. So then once we have the input embedding, we use Atlas Vector Search through a MongoDB database to find the most relevant chunks. And then we take the most relevant chunks, and again, this uses cosine similarity, but then we find that we take the most relevant chunk, and then we pass that along with the user's message or question to the fine-tuned LLM endpoint, which is also deployed through Hugging Face. Again, it's also a dedicated endpoint. And then after a few seconds, the model returns a response, and then that response we're using to populate the front end and show it back to the user.
So for evaluation, we used classic metrics. We used precision recall and F1 score. So to get recall and precision, we tokenized the generated response and the actual response. And then we took the intersection of those tokens and compared them to the length of the actual tokens and length of predicted tokens. So for precision, we got 57.7%. For recall, we got 59%, and F1 score is 54.7%. So then we also did custom metrics. So the first one is stringent factual accuracy. So those are the questions that have specific numbers, yes or no, and they have more requirements. And so we did cosine similarity with an average of 60%. But in addition to cosine similarity, we did human evaluation where we counted how many requirements were in each question to denote it as a correct, or how many requirements in the answer to denote it as correct answer. And then we looked at how many of those requirements were seen in the response by the LLM, and we got an average of 78%. For similar question consistency, the LLM should be able to receive questions that are worded differently, but get to the same point and output the same answer. And we got an average cosine similarity for that of 53.1%. And then language structure testing, the LLM should be able to handle questions that are structured differently. So that would be like an indirect question, negative question with negative compounds, direct question, or compound sentences. And for that, we got a 61% average cosine similarity.
And we have just a couple of conclusions and possible future directions before moving on to the demo. So as we talked about in the earlier slide of the evaluation, there are certain areas where the model excels, and there are certain others where it doesn't really fare well. And when using the Hugging Face trainer, which has its own inbuilt version of loss, it did really well. It got around 0.2 loss for after 200 epochs. But clearly there are still some improvements that could be made. And so we think one of those improvements could be just you changing the model itself. We did try just to see the comparison using Mistral Instruct, which is a more specific base model where the instruction that we put in the prompt really helped. And so that could be a first place to start for improving it. And as well, we could have more training data, both in terms of the number of samples. We started with 700, we could certainly use more. And as well as the diversity in terms of the way the question is structured with negative connotation and the length of the answer from anywhere from one word to a couple of sentences to whole paragraphs. And again, while the model was able to learn well, but demonstrated by the Hugging Face loss and some of our custom metrics, the answer quality still heavily relies on the number of training samples, which was not too many for our case. The chunk size, which was 150 right now, but it could still be improved more to give it more context to the model, and as well as the number of output tokens, which also limits what the model can generate as an answer.
All right, so now for the demo, I'm going to be sharing my screen for this. So over here we have the front end, again, which is a Next.js, was built with a Next.js framework. As you can see, it's very clean, and it's using the Duke brand colors. So let's go ahead and try a question. Let's see, what is the API program about? And again, this is sending the message to the backend, and then it's embedding it, finding similar chunks, and then it's sending it to the model. It takes a few seconds, but we should get a response very soon. Here we go. So as you can see, it's a very comprehensive response. It touches on not only what the program is, but also some specifics about it. So I think it did a pretty good job there. Let's try a different question, maybe a little bit more specific. Could you tell me more about the modeling process and algorithms course? And again, it's doing its whole thing on the back end. We have this cool robot icon with the loading dots to kind of like make it a better user experience. So we should be receiving a response soon. So here we go. It's talking about the modeling process and algorithm scores, talks about what it is. And I think it's a pretty accurate description. So did a pretty good job there. I want to try maybe something a little bit more different. So maybe a student is curious about housing options in Durham. So let's see how it does there. And I think currently the thing that really, it spends the most time on doing is just model inference. So we think that maybe if we ran this on more, GPU capability, it would be a little bit faster. But here we have it. It's a pretty good answer, and it mentions some specific resources like Duke List and then International House to find students, help students find roommates. So it's overall a pretty good response as well. So yeah, I mean that is pretty much our presentation. That's AVA. That's our model. Thank you so much for listening.
Thank you.